links. Good evening once again. Now, ang topic nga i-share ko sa imo sa reinforced concrete design is the beam, reinforced concrete beam, reinforced for compression or doubly reinforced beam. Therefore, the doubly reinforced beam is having this principle. Okay, this is the beam section once again. This is AS, gross depth, effective depth, width of beam. Then the additional here is the compressive reinforcement, A prime S. Therefore, compressive reinforcement having a cover of D prime, the same as with the tensile reinforced beam. Therefore, the same is true. The neutral axis should be established and the strain diagram. Therefore, for the strain diagram, still the ultimate strain in concrete is equal to 0.003. Then for steel, tensile steel, ES must be greater than the yield strain equal to Fy divided by ES. Then the distance of the ultimate strain in concrete is C, while that of steel is D minus C. Therefore, steel is the neutral axis. Okay. Therefore, in addition, here is the strain of the compressive reinforcement, E prime S. Okay, therefore I will write it here. E prime S should be equal to or greater than the yield strain, so that it will follow the code requirements of reinforcements should yield and should first to be failed over the concrete section. Then the second is the stress diagram. For stress diagram, still the same principle. For single reinforced beam, beta sub 1 times C. The maximum stress is 0.85 F prime C. Then there is compressive steel reinforcement and the compressive concrete, and the total tensile steel equal to T1 plus T2. T1 is the amount of steel reinforcement intended for the compressive concrete section, while T2 is the amount of tensile reinforcement intended to meet the compressive reinforcement. Therefore, in this stress diagram, this can be dissected to two separate stress diagram. Therefore, the first can be presented as for the concrete C sub C, while here is this T1 as equal to AS1 Fy. And this can be added by the compressive reinforcement, P2, which is equal to AS2 Fy, and here C prime S is equal to A prime S Fy. Meaning that if both tensile and compressive steel reinforcement are yielding, it is obvious here that by summation forces horizontal, C prime S is equal to T2. Therefore, A prime S Fy as AS to Fy. Therefore, A prime S is equal to AS2. In determining the balance still ratio, because the balance still ratio is the one to determine the maximum still ratio that the actual still reinforcement will not exceed, to ensure that it is following the code provision. Therefore, as we said, the balance still ratio is equal to the ratio of the total reinforcement divided by BD, which should be not greater than the maximum still ratio, equal to 75 of the balance still ratio. Therefore, there is a bar to differentiate the singly reinforced balance still ratio with the doubly reinforced. And the same, the actual still ratio should not be less than the minimum of 1.4 divided by Fy. How can we determine the balance still ratio? Therefore, by taking summation of forces here, okay, C prime S, C sub C, and T. Therefore, we can say that T is equal to C sub C plus C prime S. Therefore, it is here AS times Fy equal to 0.85 F prime C AB. Okay, the same as the singly reinforced beam, but we have an additional here of A prime S Fy. Okay, presuming that all the reinforcement are following the yielding condition as required by the structural code. Again, you have here AS as rho D, rho BD Fy, 0.85 F prime C AB, plus rho prime BD. Therefore, rho prime is intended for the compressive reinforcement still ratio. Therefore, now rho here as the rho balance is equal to 0.85 F prime C, but A is already accepted as beta sub 1 times C times B divided by BD Fy plus rho BD Fy divided by BD Fy. Where does this BD Fy came from? Therefore, it came from here. Now, analyzing this and then cancelling like terms, BD Fy is cancelled. B here is also cancelled. Therefore, the balance still ratio bar, which is the balance still ratio for doubly reinforced beam, is equal to 0.85 beta sub 1 F prime C over Fy times C over D plus rho prime. Therefore, it is understood already that C over D, as we have derived before, to be C over D is equal to 600 all over 600 plus Fy for balance condition. Therefore, we need to substitute this value to this value. Therefore, we now have rho balance as equal to 0.85 beta sub 1 F prime C over Fy. Substituting C over D here with 600 plus over 600 Fy. Therefore, we have here 0.85 beta sub 1 F prime C times Fy divided by Fy, 600 divided by 600 plus Fy. But we have still rho prime here for the compressive reinforcement. Therefore, we need to add it here, meaning that the balance still ratio bar is equal to the balance still ratio of a singly reinforced beam plus rho prime. Therefore, now for the maximum still ratio is equal to 75% of the balance still ratio. is equal to 75% of row balance plus row prime. Therefore, this is now the derivation of the balance steel ratio of a doubly reinforced beam.